I want to welcome you to the second lecture for college algebra, MAC 1105. My name is Jorge. So for this particular lecture, we have several objectives. And the first one is that we're going to solve a quadratic equation by factoring. We're going to solve a quadratic equation by completing the square. We're going to solve a quadratic equation by using the quadratic formula. And then we're going to go ahead and solve problems that can be modeled by the quadratic equation. And that should have an A there. So what's a quadratic equation? So definition of a quadratic equation. Quadratic equation in X is an equation that can be written in the general form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a does not equal 0, because if it does, it would just be a linear equation, bx plus c. And another name for a quadratic equation in X is just a second-degree polynomial equation in X. Now, quadratic equation can be written in the form of ax squared plus bx plus c equals 0, and this is what we call standard form. So there are three methods for solving a quadratic equation. The first one is factoring, the second one is completing the square, and then the other one is using the quadratic formula. So I'm going to go through each one of these steps in these two lectures. So the first property that I want to talk about is the zero factor property. So the zero factor property states that if a times b equals 0, then either a or b or both are equal to 0. So make sure that the quadratic equation is written in standard form before using the zero factor property. So here we have an example. We're going to go ahead and solve this equation. So we have x times x minus 4. So what we do is we set each one of the factors equal to 0. So x is a factor and x minus 4 is a factor. So the first one is already solved, right? X equals 0. Now the other one we have to solve for x, which gives us that x equals 4. So the solution set for this particular equation would be the set 0, 4. Now, if I go back to the original one, if I multiply out the x, I would have ended up with x squared minus 4x. So here we have another example. So we have x squared equals 6 minus x. So the first thing that I want to do is I want to make sure that I write it in standard form. And by writing in standard form, I'm going to have 0 on one side of the equal sign. So I'm going to subtract 6 from both sides. I'm going to add x to both sides, and I end up with the quadratic, which is x squared plus x minus 6 equals 0. So now I'm going to go ahead and factor this. So the way that we factor this is I look for factors of 6 that add up to 1. And what I get then would be x plus 3 and x minus 2. 3 times negative 2 is negative 6, which is the negative 6. And if I add 3 plus negative 2, I get 1, which is my x there. So then if I solve, set each one equal to 0, and I solve, I get my solution set, which is negative 3 and 2. So that's my solution set. The next method that we're going to use is the square root method. Now, if x squared equals p, and p is greater than or equal to 0, then x is equal to the square root of p, or x is equal to the negative square root of p. So here we have two examples. So the first one is x squared equals 7, and b would be x plus 3 squared equals 9. So the first one, if I take the square root of both sides, then x is going to be equal to plus or minus the square root of 7. So either x is equal to the square root of 7 or x is equal to the negative square root of 7. So my solution set would be the one that's shown there. Now the next one, x plus 3 squared equals 9, what I'm going to do then is I'm going to take the square root of both sides. That's going to get rid of the square, so I end up with x plus 3 equals plus or minus square root of 9. And then we know that the square root of 9 is just 3, so then I end up with x plus 3 is equal to plus or minus 3. So now if I separate these two, I end up with x plus 3 equals 3 or x plus 3 equals negative 3. So I solve each one for x. So the first one, x equals 0 or x equals negative 6. So my solution set would be 0, negative 6. The next one that we're going to do is we're going to go ahead and solve the quadratic equation by completing the square. So we have 2x squared plus 6x minus 5 equals 0. So when we complete the square, we sort of get away from the standard form. So the first thing I want to do is I want to move my constant, my negative 5, over to the other side. So now I end up with 2x squared plus 6x equals 5. Now the next thing that I want to do is I want my leading term, the coefficient, to be 1. So I'm going to divide everything by 2. And what that's going to do for me is it's going to give me a leading term of x squared as opposed to 2x squared. So I divide each of the terms by 2. And then when I do that, I end up with x squared because the 2's cancel out. 6 divided by 2 is 3. And then I got 5 over 2. Now, the next thing, and this is where this 9 over 4 comes into play, is that I add I add b over 2 squared to both sides. Now, b is 3, so I do 3 divided by 2 squared, and I'm going to add that to both sides. Well, 3 over 2 squared is 9 over 4. So I'm going to add 9 over 4 to both sides. And so at this point in time, I have my next step, which is x plus 3 over 2 squared equals 19 over 4. So now, how did I get to this point? First thing that I do here is I get rid of my deleting term of my equation by dividing by whatever that value is. So I end up with x squared plus 3x plus 5 over 2. The next thing is that I take this b and I divide it by 2 and I square it. So 3 over 2 squared is 9 over 4. And I'm going to add that to both sides. That ultimately gives me 5 halves plus 9 fourths is 19 over 4. Now, this right here, this part of the equation, x squared plus 3x plus 9 over 4, is equal to x plus 3 over 2 squared. So the nice thing about completing a square is that if you remember, we added 3 over 2 squared to both sides. Well, that becomes my constant here. So this sign determines what this sign is, and then I just square it. So x plus b over 2 squared equals, and then I just add up this side over here. So that's how we ended up with this. Now this we can solve because we already know how to solve that. So we square root of both sides, and then we subtract the 3 over 2. So then x is going to be equal to plus or minus square root of 19 over 2 minus 3 over 2, which then I can further break down into x is equal to square root of 19 minus 3 divided by 2, or negative square root of 19 minus 3 divided by 2. So the next thing that I'm going to do is I'm going to use the quadratic formula. Now consider an equation, ax squared plus bx plus c equals 0, a does not equal 0. If b squared minus 4ac is less than 0, then the equation does not have any real solutions. If b squared minus 4ac is greater than or equal to 0, then the real solutions of this equation is or are given by the quadratic formula x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So again, if b squared minus 4ac is less than 0, no real solutions. If b squared minus 4ac is greater than or equal to 0, there's either one solution or two solutions. So again, let me go over that again. So the discriminant is that b squared minus 4ac. So for a quadratic equation, ax squared plus bx plus c equals 0. If b squared minus 4ac is greater than 0, you have two unequal real solutions. If the discriminant b squared minus 4ac is equal to 0, then there's a repeated real solution, and it has a root multiplicity of 2. And that would be such as it's going to be x minus 2 squared. If b squared minus 4ac is less than 0, there are no real solutions. So let's go ahead and use the quadratic formula to find any real solutions for this particular quadratic. So here we have 2x squared minus 4x plus 1 equals 0. So this is in standard form, so it's ax squared plus bx plus c. So then b squared minus 4ac, given this particular equation, is going to be equal to negative 4 squared minus 4 times 2 times 1, which gives us 8. Now, since b squared minus 4ac is greater than 0, then there are two real solutions that we can find by using the quadratic equation, or the quadratic formula. So here's the quadratic formula. We're going to plug in the values that we have. So, and then we're going to go ahead and solve. So x is equal to 4 plus or minus square root of 8 over 4. We're going to further simplify that to 2 plus or minus square root of 2. Now, 8 is equal to 2 square roots of 2. We take the 2 out, and then we can reduce everything that we have. So that's how we end up with 2 plus or minus square root of 2 over 2. So my solution set for this particular equation then is 2 plus square root of 2 over 2, or 2 minus square root of 2 over 2. So here we have another example. So we have 1 half x squared minus 6x plus 18 equals 0. So we're going to go ahead and solve it. So the first thing I want to do is I want to get rid of that 1 half. So I'm going to multiply everything by 2. Multiplying everything by 2 gives me the equivalent equation x squared minus 12x plus 36 equals 0. Again, ax squared plus bx plus c. So I'm going to find out if I have any solutions. So my discriminant comes out equal to 0. So then, since it's equal to 0, there is a repeated solution. So this is the one that has the multiplicity of 2. So I'm going to go ahead and find that, right? So using the quadratic formula, I plug in the values that I have on a, b, and c. And then I get 12 over 2, which equals 6. So my solution set is just 6. So here we have another example. 2x squared plus 3 equals 2x. First thing I'm going to do is I'm going to move everything to the left side. Then I have my a, my b, and my c. My discriminant is equal to negative 20. So b squared minus 4ac is equal to negative 20. Since it's less than 0, there are no real solutions. I can move on to the next example. So here we have a quadratic equation. So we have 6 plus 1 over x minus 2 over x squared equals 0. So what we're going to do is we're going to multiply everything by x squared. By multiplying everything by x squared, we end up with 6x squared plus x minus 2. So the first thing is I'm going to go ahead and find out my discriminant to see if I have any solutions. And by plugging that in, I find out that my discriminant is equal to 49. Now, since it's greater than 0, I have two real solutions. So I'm going to go ahead and use the quadratic formula. Plugging in the values of a, b, and c into my quadratic formula, I end up with negative 1 plus or minus square root of 49 over 2 times 6, which simplifies to negative 1 plus or minus 7 divided by 12. So then I have my two solutions. So negative 1 plus 7 divided by 12 is 1/2. Negative 1 minus 7 divided by 12 is negative 2/3. Those are my two solutions, and here's my solution set. So I'm not going to go through each one of these because this is available to you, but the procedures for solving a quadratic equation: identify a, b, and c, evaluate the discriminant, and then from there go on. So this is the end of part 1 for lecture 2. In the next lecture video, we're going to talk about complex numbers. Thank you.